So this is the Unit 4 seminar, incorporating algebra tiles to explore the concepts of addition and subtraction with algebra, polynomial equations, as well as we're going to talk about the distributive property today and how to illustrate area or multiplying polynomial by monomials with algebra tiles. So the algebra tiles are there to help you kind of understand the rules of the distributive property, multiplication, and combining like integers. But after the next unit, we're not going to be using algebra tiles. We're just going to be concentrating on the rules of algebra, basically, okay? So this is just to give you a visual representation. So let's start off with the first example. If we write 3x squared, so if our first trinomial is, let me fix this. Well, any second now. So Unit 3 was a big review of like the basic concepts behind the algebra tiles. So you'll notice if we look at the bottom of the page, x squared is usually represented by a big square. Whenever you have the x terms, those are usually skinny rectangles, or the y terms as well. And unit cubes are always used as tiny little squares. Remember, it's important to use different colors for positives and negatives, and very important to make your x and your y's, or label your x and your y's, because they tend to look very similar, so we're able to differentiate them. So if I have an equation like 3x squared minus 5x plus 7, and then I'm going to add that to 4x squared minus 3x minus 5. Notice, because there are no brackets, the distributive property isn't involved at all. But if I ask you in your unit guide to illustrate this using algebra tiles, actually that's going to be one example. We're going to come back to this because I think we should start off with a more simple example first. So let's start off with the equation 9x minus 1 plus 2x minus 3. Now, because we do not have to use the distributive property, it's probably very simple for you to solve this in your head or just using combining like terms. But in your Unit 3 guide and somewhat in your Unit 4 guide, you're going to be expected to use algebra tiles. So because I have a positive 9x, basically I'm going to just draw 9 of these. 2, 3, 4, 5, 6, 7, 8, 9. And notice that they're all the same color because we have a positive value, okay? Let's just switch this up a little. I'm going to make this a negative 2x. So I have positive 9x and negative 1, so 1 negative unit cube, okay? Now, when I have to subtract 2x or add a negative 2x to it, basically the negative x and this negative x cancels out 2 of my positive x's. So how many positive, well, first of all, do I have more positive x's or negative x's? Positive. So I know my answer is going to be positive. How many positive x terms or algebra tiles do I have? How many are up there? Rita? Yes. So I know the simplified expression is going to have a positive 7x. So the negatives and the positives cancel each other out. Now I know with this negative 1, I have to add 3 more negative unit cubes. So 1, 2, 3. And notice there are no positive unit cubes to cancel the terms out. So how many negative unit cubes, unit tiles do I have altogether, Drew? Negative units? 4, right. So my final answer would be 7x minus 4. So I already know that the rules for subtracting or adding and subtracting common integers is we would take my -1 and the -3, add the numbers together and keep the sign the same. But if you're having trouble figuring or remembering the rules, algebra tiles are a good thing to use to help jog your memory, okay? So, and this is how you would illustrate that in your unit guide. So take a second and just copy what you see on the board, and then we're going to move on to the next question. Does everyone have a seminar sheet? Yes? Okay, good. And please write down a note to yourself to make sure you're using colors when you do the algebra tiles. Otherwise, I will not be able to figure out if it's positive or negative. Yep? Yes, that's fine as well. Okay, let's go to the more difficult question. So I have a positive 3x squared. So I know I will need 1, 2, 3 of these. Okay. I have a negative 5x. So 1, 2, 3, 4, 5. And let's fix this a little bit, make that positive. I have I have a positive 7, so that's going to require 1, 2, 3, 4, 5, 6. I feel like I'm on Sesame Street. 7 unit cubes. So does that look right? So my trinomial, because there's 3 terms here, 3x squared minus 5x plus 7, I have attempted to illustrate using algebra tiles. Now, when I combine the next trinomial, 4x squared plus 3x minus 5, I'm going to deal with like terms first in case any positive terms cancel out the negative terms in order to try to get the final simplified expression. Okay, so first of all, I'm going to add 4x squared to my 3x squared. So that means 1, 2, 3, 4. So how many x squared terms do I have altogether? Yep, 7. Good. So I have positive 7x squared. The next one's a little different because I have a positive 3x. So I'm going to map my positive 3x to cancel out that negative x. Positive 2, positive 3x. Okay, so these 3, because the positive and the negatives canceled each other out, these no longer exist, have no terms there. So all that is left is negative 2x, okay? So the positives and negatives have canceled each other out, so that's a 0, 0, 0. So I'm left with negative 2x. And if you check, negative 5x plus 3x is negative 2x, so that's correct. Finally, I have to add negative 5 units to my unit tiles. So this is going to cancel out 1, 2, 3. Why didn't that cancel out? That doesn't want to cancel out. Okay. 1, 2, 3, 4, 5. So when I add the negative 5 to it, so this is now a 0, this is a 0, 0, 0, 0. So how many units do I have left? Unit tiles. Yep. 2. Is it a positive 2 or a negative 2? Positive 2. Good. So this is how you will be showing me adding and subtracting when you are using algebra tiles.